is homework. Who's got homework questions? Remember, I'm recording, so. Yes, sir. Tell me what it is. All right, what would be the first thing I would check for? Do they have a GCF? 4, 35, and 49. I always start with the smallest number. What are the only factors of 4? And 4. 4 goes into 2 doesn't go to any of those. 4 doesn't go to, so we can move on. No GCF. Does that make sense? Number 12, is that what this is? All right, 2 ways to do this. Didn't I teach you perfect square already? Why could I check that this is a perfect square? What does this have? 2x is its square root. What's the square root of this? 7. Is this a plus sign? When I multiply this times this, I get to 14x. When I double 14x, does it get me to what's here in the middle? So guess what? It's not a perfect square. So then I try to do 4 times 49. Not right now, I'm teaching. Can you do it tomorrow?
No, I have to try it today.
Can you come between classes?
Yeah.
4 times 49 would be what? What's 4 times 50? 106. Try again. 200, but minus 4. Do you guys understand why I did that? I don't have 50 fours. I have 49 fours. Do you guys get what I'm saying? 50 times 4 would be 200. If I take one of those 4s away, I get 196. That's how you can multiply in your head without using a calculator. So I need 2 numbers that multiply to 196, but what? So get out your calculator. 196 divided by 12. Try it. Does it work? No? Okay, I'll do it myself.
Yes, it works. I think it's like 16.
Doesn't work.
Seven and 28.
196 divided by 7 is 28. No. You tell me why. So we don't have to worry about which one's which. So I put x minus 7, 28. Divide by 4, divide by 4. This does not simplify. So I pull that forward and it becomes 4x minus 7. This one does simplify, x minus 7. Yep. Tell me what it is. Did you pull out a greatest common factor first? What is it? You did pull that out? Okay, so you got 4 v squared minus v minus 2. No. This is 4v right here, right? I'd take it out from all 3. That's why it's a greatest common factor. It has to be into all 3, because what is this? Hey, when I put this 4, who does it belong to? Everything inside here. So it's going to go to this one, it's going to go to that one, and it's going to go to the 2. That's why it's a greatest common factor. It has to have all of them. See where you made your mistake then? Do you need me to go over it anymore, or no, you got it now? This would be different signs, two numbers that multiply to 2 that subtract to 1, 2 and 1. So it should be 4v minus 2v plus 1. By the way, most of the answers for us, and I'll probably give you some new, there might be new worksheets tonight for homework, there might not be. Pay attention to the notes and if there's any new attachments. But normally when I give you a worksheet, I try to find ones that have the answers. Make sure you scroll all the way to the bottom because it's not about the answers, right? It's about how you get there. So I don't care if I give you the answers. Check your work. No, not the test. No, on the homework, I don't care. You can see that I don't even really check your homework that much, do I? Because it's not about me. It's about you putting in that effort, trying to get it. I'm just giving you 5 points just to be nice. Homework questions. All right, so the next ones we need to go over. We did perfect squares, yes? Does anyone have any questions on perfect squares? No easy way, just know the pattern. What has to happen for me to have a perfect square? There's 4 things that have to happen for it to be a perfect square. What has to have a square root? The first number needs to have a square root. The last number needs to have a square root. Needs to be, the last number has to be a positive. And then finally, the 2 square roots multiplied together, doubled, have to be in my middle. Then I know. But I mean, it shouldn't take that long to test. It's really not that long of a test if you think about the versus doing it the long way. So like, if I had this, which we've done this one before. I do GCF, they don't have anything in common. This right here, I just kind of go, okay, the square root is this, the square root is this. That's a plus sign, multiply together, 6x doubles that, boom, it's factored. 2x, 3 squared, the sign comes from right here. I mean, it really should, once you start getting the pattern, it doesn't take long to test. And it's just a test because, could I do this the other way, the long way? Yes. 4 times 9 is 36. It still would work. I need same sign, so I need to add. I need 2 numbers that multiply to 36, but add to 12, 6 and 6. X plus 6 over 4. X plus 6 over 4. Why is it over 4? Because that's not a 1, right? Reduce this. This turns into 3 over 2. 3 over 2. Pull the 2 forward. I get 2x plus 3. 2x plus 3, which is the same thing as 2x plus 3 squared. It's just much faster doing it this way. Does that make sense? 4 things to test for it's a perfect square. Difference of squares, new one. Difference of squares. I'm going to show you what it looks like factor. And remember, by Friday, we're going to tie this all together with how this relates to what I'm talking about, which was parabolas. Right? Don't lose that. It's going to still relate to parabolas. In fact, if you look at them, isn't that standard form of a parabola? And haven't we been changing it to this, which is called factored form of a parabola? We're going to talk about what factored form is good for on Friday. Okay? But it is still a parabola. You with me? So let's look at what, don't write this, just watch. This is what difference of squares look like factored out. This is what they look like when they're factored. What do you notice about that? No, they're not the same. They cancel each other out. This is the standard form. This is what I will give you, and I'm going to need you to get back to here. So I want you to look at a pattern and see if you can see what happened. By the way, this is called a perfect square because it has a square root, and it's a nice, pretty number. That's a perfect square because it also has a square root. It's 2, right? So both of those are called perfect squares. And what is in between them? What is in between them? It's a subtraction sign. Also known as, if I said, what's the difference between 2 and 1, right? Difference means subtraction. So what did I say that this is going to be called? Difference of squares, because both these are squares and there's the difference. Difference, subtraction of two squared numbers. So how will you know that you're dealing with a difference of squares? First off, what's the big difference between everything we've done in the past to this one? Which means there's only two terms. There's only two terms. That's a huge key that says, hey, you might have difference of squares. What else do I know about this number? It has a what? It has a square root. What about this back number? It also has a square root. And what's in between them? For now. Algebra 2, I'm going to teach you how to do it when there's a plus sign. But for now, it has to be a minus. So here's what happens. Whoop. How do I recognize that this is a difference of squares? Two terms. How else do I recognize it? That is a square root. What is it? This is a square root. What is it? And what's in between them? When the second sign was negative, what did that tell me? One was positive, one was, and then you just put the square roots in here. It's really, when you see difference of squares, you should be like, oh, thank goodness. Those are super easy. Why do I possibly have difference of squares? Why do I possibly have it though? I know that, and I'm trying it because it's easy right now. This has a square root, this has a square root, and that's a what? So then, like you said, what's the square root of this? X, what's the square root of that? 5. Put them both in. 1 plus, 1 minus. Difference of squares, when I see them, I'm like, thank you. So easy to factor. No, difference of squares can only be 2. Because what happens in difference of squares every time? What happens to the middle term every single time? So in difference of squares, it can't have a middle term because that's what difference of squares do, is that you have the same exact thing, but one positive and one negative. So no, middle term cancels out. What's the square root of this? What's the square root of this? Just careful. And actually I screwed up. Whoops, I messed up. Nope, I messed up big time. Bad, Mr. Martin. I realized it after I did it. What should I do first? And guess what they do? So I should have turned this into this. That's my fault. Now I check. What's the square root of that? What's the square root of this? And then I would end up being x plus 2, x minus 2. You've already graphed stuff like this. It's parabolas. This is standard form of a parabola. Opposite of b over 2a would get you the x coordinate of the vertex. Plug it in and you find the y. The same stuff still applies. This is still a parabola. These right here are the intercepts. We're going to talk about that though on Friday. We'll talk in a little bit. We'll tie it in on Friday. Let me just get factoring down. Because like I said, factoring is going to go even farther than this chapter. But yes, I like that you guys are trying to apply it to, because there is a bigger part of this. All right, what if I did, What do I do first? And what's the GCF of them? Gotta pull that. Right now, is this the difference of squares? Because this one doesn't have a what? This one doesn't have a square root. But when I pull that 3 out, what all of a sudden pops up? Numbers that have square roots. So if I didn't pull that GCF out, I wouldn't think it's factorable. Do you see what I mean by that? And then what would be my answer down here? No. What's the square root of this? 2x, not just x. What's the square root of this? So it'd be a 2x and a 5, a 2x and a 5, 1 plus, 1 minus. Garrett, you with me? You sure? Questions on difference of squares? All right, next one I have to do is called factor by grouping. Because both numbers have squares or square roots. So both numbers are squares and your difference of them because it's a subtraction sign.
That's what I thought. I just wanted to make
Yep.
sure I scared you where it said, like,
You're good. The next one is called factor by grouping. Please pay attention to this one. This one's a little bit more of a pain in the butt, but once you see it, it's not bad. I don't know if you did, but I went through middle school and teachers taught me all this kind of crap, and I thought, why are you telling me this? It's so stupid. Yes? Yes. Yes, because it is so important. So like one of the things they taught you is 3 times 2 and 2 times 3. They would say, that's the same thing, 6. And you're like, oh my gosh, yes, it is 6. What is the big deal, lady or dude? It's not a, you keep freaking saying this stuff. But it does matter because when I get to here and I have in my parentheses x plus 2 and I have x minus 3, I'm telling you this is the same thing. And there are some times that I need to reverse this order. And that's the commutative property being used in a much bigger sense. Because they don't, you wouldn't be able to handle that because you haven't learned. You're like, right, you can't go.
Why can't you just say, we need it later?
They do say that, you just don't hear it. It's just like when someone says, trust me, this is what you need, it'll be better for you later on. You're like, but it's not good for me now. We're just so hard to, that's why it's like crazy when you get to be an adult and you look back, you're like, dang, I wish I would have listened to these people. It's like in almost every generation says that kind of thing. Why didn't I just do what I was supposed to do then? I know. I didn't. I still talk to people who are not, I still talk to people who are out of it, and I'll be like, can you believe that they're struggling with this? And like, really?
Are they
There's no. No.
My mom sucks at math, and she's awful at it. So the only math she can do is
Sorry, Mom.
Oh, yeah.
multiplication and division.
She does more than that, I promise. She just doesn't know it. All right, so there was a rule. You guys learned about commutative. Anyone know any other rules that you learned about? Distributive, we use that. That's not what I'm looking for this one. Started with an A. The associative property. And you're like, what is that? That's so stupid. Again, it's one of those ones that are like 2 plus 3 plus 4 is the same thing as if you did 2 plus 3 plus 4. You can put parentheses in there like, wow.
So cool.
Well, it actually is cool right here because we're going to use that. Do you see how all these things are being added to each other? So I can put parentheses here and here. And then what happens is, do you see how I have an a cubed and an a squared? I can take a GCF out between these two. Yeah, I don't know what that was. What do they both have in common? They have a squared in common. And then what am I left with? So remember, I told you that you should always be able to go back to what you started with, right? If I multiply a squared times a, what does that get me to?
Oh,
Because what happens when I multiply a squared times a? It gets me back to a cubed, but I also needed an a squared. What do I multiply by to get back to a squared? 1. So this would be what you need. You cannot forget that 1. That is definitely something that people forget a lot. That's why I let you sit there and struggle with it, because hopefully it'll help you remember what to do with it. Okay? Try it again. You're going to actually have another chance to do this. What do the next ones have in common? What do these guys have in common? 9. What the greatest? Okay. What am I left with? A plus 1. Now, watch this. This is a bigger part. This right here and this right here. Do you see this plus sign between them? This is one term and this is another term. What do these two things have in common? Nope. So I pull out the a plus 1 that they both have in common, and then I multiply by what's left over. What's left over here? A squared and a plus 9. That is called factor by grouping. Yep. Careful on this one. Careful on this one. No, it's minus minus now. No. Careful on this one. When I go to do my associate property, what did I say has to be between them? A plus. Do you remember back again? It's another one of those things that they taught you in middle school, and you're like, I don't understand why they're teaching me this. It seems pretty stupid. 5 minus 2, how can I rewrite that as? 5. Nope. Nope. Plus a negative 2. You can kick the negative to that. Where can I do that here? I'm going to put my parenthesis, but instead of thinking this as a negative, I'm going to go plus a negative 9a, like that. I'm going to kick a negative inside there with that. That is a big deal. Because now when I do this, what do these guys have in common still? A squared, and I'm left with a plus 1. What do these guys have in common? Now, if I pull out only a 9, watch what happens if I only pull out a 9. I'm doing this stuff on purpose. I'm left with a negative a and a negative 1. Is this the same as that? The only reason you want to do this is if you can get the same bubble here as the same bubble here. That's the only way that factoring by grouping is going to be worth anything. When you do the grouping, you should get the same thing in this bubble as you do this one. If you didn't, either you messed up or you can't factor it by grouping. Are you hearing me? Both instances are going to happen to you. You're going to factor it one time wrong, and that's why you're not going to get it. So you need to go back and check it. And then sometimes it's just not factorable by grouping. It is factorable. It's just not yet. Again, your factoring skills right now are only in algebra 1, and they're this big. I'm going to make your factoring skills this big in algebra 2. No. Let me finish this one. So, hey, come on. A plus 1. So what do I want to pull out instead? And when I pulled out the negative 9, I get a plus 1 because a negative 9 times a positive 1 kicks me back to that. And then, what do these both have in common? And then what am I left with in the other bubble? No, not 2 squared. What in the world? A squared minus 9. What's left over? A squared minus 9 goes in the other one. Now, be careful. I'm hitting you with a lot. Please be careful. What should you recognize this as? I literally just taught it to you. That's why I taught it to you before I did this one. Difference of squares. And so actually you can factor that bubble more. A plus 3, a minus 3. You have to factor until everything is factored. Yes. Welcome to Algebra 2 starting now. We're starting to get to Algebra 2. Huh? We'll get, don't worry about where we're going. We'll be all right. Does this make sense? What part's not making sense?
I'm just tired.
Okay. Do you understand the factor by grouping? And then once I did this, I have to relook at that and realize that's a difference of squares, and so I had to make it, I have to factor until it's fully factored. All right, try this. No,
Am I just reading the clock wrong?
you're tired.
Yeah, that's what it is. I read 53. I did say that. It's 20 minutes.
Hey, let's go try this one.
Oh, yeah, I said that too.
All right. How do you know what gives you a clue that you're possibly going to do this by grouping? Four terms is what's going to tell me, because in order for me to really factor this by grouping, I got to be able to go, hey, you go in a group, and you go in a group. And how come I can cut that 4 off from its positive sign? When I just cut it off, what is that 4a still? Still positive. Do you get what I mean? Okay, so right here, what do these guys have in common? 3a squared, and what am I left with? 4a minus 3, yes? What do these guys have in common? So it's just 4a minus 3. What do these two things have in common? So 4a minus 3. Now what's left over outside? Good. What's left out here? A plus 1. Because there is something there, it's just not written, it's a plus 1, so that plus 1 goes right there. There it is, factored as grouping. Now, I would try to look at this and see if I could factor it, which I can't, so that's done. Does that kind of make sense? Try that one. Don't freak out because it's got X's and Y's and all that stuff. Just do what we talked about. What does it mean when you have X, Y? Just means 35X times Y. $35. All right, quickly. I go to group these together. It's fine just to group these. What's the problem when I go to group this one? Stick the negative in there, but what do I have to put between these two? Why? Why can't I leave it like that? What would it look like if I had two bubbles next to each other? Exactly, and I can't, so I got to put a plus sign there. Okay, what do these guys have in common? 5x. What am I left with then? 7y. Good. What do I need to pull out? So remember, I'm kind of cheating. Do you see how this is a 7y minus 1? What do I want this back parenthesis to look like if this is going to help me? I want it to look like the same, right? So I kind of cheat. I'm like, okay, I know I want this to be a 7y, so I'm not going to pull out a positive number. I'm going to pull out a negative 8. And why would I do that? Because when I pull out a negative 8, what am I left with then? Positive 7y, and then a minus 1, and then boom, I made it to where both of these have the same thing. So I'd go 7y minus 1, and then what's left in my other parenthesis? 5x minus 8. That's called factor by grouping. Does it make sense a little bit more now? Okay, go out practice on that tonight too. You'll possibly have 3 different worksheets. Please make sure you read the notes because I'm not giving you the entire worksheet to do. I'm only going to pick certain questions that are going to help us with what I want, and I'm picking ones that are weird ones so that you ask me questions, the ones that you need to help with on the for like test, so that we get better at this. Make sense? Oh, yeah.